In the name of Almighty Allah, the most merciful and the most beneficent. Well, students, welcome you all in this bright session of week 5. I am your physics teacher, Habibur Rahman. Our objective is to discuss mass measuring instruments in today's session. Instruments which we have to be focused. First one is beam balance, second one is physical balance, third one is lever balance, and the fourth one is electronic balance. We will discuss these 4 mass measuring instruments one by one. The first mass measuring instrument which was introduced by the ancient people is beam balance. Its shape is like this. This beam balance consists of 3 things. First one is the beam, due to which we name it beam balance. This whole beam is holding 2 pans. You can say these are the scale pans, the left pan and the right pan. Along with that, there is a pointer on the beam. If the pointer shows you the 90-degree angle, then you can say that both masses are equal. The method of taking measurement about mass by using beam balance is that we have to place one thing on the left pan and the standard masses, or you can say the known masses, in the other pan. When both masses will become equal, the pointer will show you the 90-degree angle. This is how beam balance works. And the very important thing in it is that we must know about the least count of this beam balance. And the least count of this beam balance is 0.1 gram or 100 milligram. As you all know that least count is the minimum reading which we can take from any instrument. The minimum reading which we can take from any measuring instrument is the least count of that particular instrument. So the least count for beam balance is 0.1 gram or 100 milligram. Concerned, the shapes are in front of you. Physical balance is also a mass measuring instrument, and it is more precise and sensitive than a beam balance. Keep this thing in your mind. It is the most sensitive and more precise than the beam balance. Why we are saying that this is precise? Because the least count for why this physical balance is precise, because the least count for physical balance is 0.01 gram or 10 milligrams. This physical balance is having least count less than the least count of beam balance. So that's why physical balance is more precise than the beam balance. Now come to the structure of physical balance. Here in the right side picture you can see that there are 2 pans. In one pan we have to place object, and on the right hand side pan we have to place the standard masses or the known masses, and the set of known masses we will get along with this physical balance. Here in this below picture you can see this is a physical balance, and along with that you can see the box. This box is of standard masses. Standard masses is of like this type. This is a picture for standard masses. These are of different masses and different shapes. So these masses are noun masses basically, and these masses are used to calculate the mass of something which we will place on the left hand side pan. Along with that, you can see a stirrup here. Here is a beam. This is a balancing screw for balancing the pans. This is an arrestment knob. By using this, we can pick the pans up. We can lift the pans up basically. If we want to measure mass of something, we have to lift the pans first. And how we will lift them? By using arrestment knob. Here there are leveling screws. Leveling screws are used to balance the plane over which these pans lies. And this is a pointer in the middle of the beam, in the middle of, you can say, a metallic pillar. There is a pointer here. Here you can see a pointer, this one. This one is a pointer in silver color. This one is a pointer. On the black beam, black pillar, black metallic pillar, you can see a white needle extended below. This one is the pointer. If this pointer is on 0, this means both pans are equal. And if the pointer is not on 0, it is on the left or on the right side, this shows that the pointer, the pans are not equal, the masses are not equal. So the very important thing, the device is enclosed in a box to avoid the effect of wind. This physical balance is basically used for laboratories. So to avoid the effect of a wind, this is enclosed in a box. The least count for this physical balance is 0.01 gram or 10 milligrams. Lever balance. Its pointer is like a pointer in the beam balance. Two pans are here. This is a lever here, you can see. And, well, we will place one object in one pan, the standard mass is on the other pan, and the pointer is brought to 0 by varying standard masses. If the pointer will be at 0, then you can say that both pans are equal. The least count for lever balance is 0.01 gram to 10 milligrams. Most precise and the most accurate mass measuring instrument is electronic balance. It is most precise as compared to all other mass measuring instruments. Why I am saying that this is most precise? Because the least count of electronic balance is 0.001 grams or 1 milligram. This is the minimum reading which we can take by electronic balance. As far as other balances are concerned, the least count is not so much less. In electronic balance, the least count is less, so as compared to other mass measuring instruments. So this electronic balance is the most precise one and the accurate one. It comes in different ranges, like in milligram range, in gram range, and in kilogram ranges. First of all, we have to switch it on and we have to check whether the reading is set to 0 or not. Then we will place an object on the electronic balance and the reading will gives you the mass of an object. This is all about electronic balance.